Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test, another application question. So here we're told that the gas tank of a parked pickup truck develops a leak. The amount of gas in liters remaining in the tank after t hours is represented by this function. V of t is equal to 90 bracket 1 minus t over 18 squared, where t is between 0 and 18 hours, right? So this here is going to be the domain of this function. Part A, how much gas was in the tank when the leak started? Part B, how fast is the gas leaking from the tank when there's 60 liters of gas in the tank? Okay, so part A is not going to be too bad. How much gas was in the tank when the leak started? So basically at a t-value of 0, right? What was the volume at a t-value of 0? How much gas was in the tank when the leak started? So we're basically finding V of 0. So plugging in 0 for t, we'll have 0 over 18 squared. This goes to 0. This bracket ends up being 1. 1 to the power 2 is 1 times 90. We would have 90 like this, right? So we start off with 90 liters in the tank. And just to give you a visual of what's happening, it's going to help us also in part B. What happens is this is a quadratic that's opening up here, right? And it's starting here at this t-value of 0, right? This is time, this is volume. It's starting at a volume of 90. And what happens is with time, because it's a leak, the volume is going down, and the tank is going to be emptied at a t-value of 18. Okay, that's why they limited the domain to 18 hours, because at 18, if you plug in 18 here into this function, 18 over 18 is 1, 1 minus 1 is 0, whole function, the v value is going to be 0 at 18 hours, right? So that like represents the vertex basically of this quadratic, and then it goes back up like this. If we look at it just as a function, however, because it's a word problem, we're not going to be looking at that second half, right? So this is all we're looking at for this function right here, right? From 0 to 18. Now in part B, what they are asking for is how fast the rate of change, right? The wording is important here. How fast is the gas leaking from the tank when there is 60 liters of gas in the tank? So basically what they're asking for is the rate of change, or the instantaneous rate of change, at the point where there's going to be 60 liters of gas in the tank. And so from the wording, hopefully you could tell we're going to be using the derivative, right? Because the derivative of this function is going to give us that rate of change, or the instantaneous rate of change, at any specific t-value. Now to show it on this graph what's happening, basically we have to find out when, right? So at this point here, when the volume is 60, when there's 60 liters of gas left in the tank, so at that t-value here, so we're actually going to have to find that t-value when the volume is 60, we have to figure out how fast is the gas leaking, or the instantaneous rate of change, or if you're looking at it from a graph, from a graphical perspective, we have to find the slope of the tangent at that point, right? So the instantaneous rate of change at that t-value, or how fast the gas is leaking at that t-value when the volume is 60, or on this graph, what's the slope of the tangent, because the slope of the tangent is the instantaneous rate of change at that specific t-value. Okay, so that's what's going to be happening. So there's actually two steps here. What we're going to be doing is first we have to find this t-value when the volume is going to be 60, right? So step 1 is find t when the volume, when v is equal to 60. And so to do that, let's plug in 60 into the original function, right? So notice at this point, we're not working with the derivative at all, right? We're still working with the function. We're just trying to find the t value when the v value is going to be 60. So this is going to be 90, 1 minus t over 18 squared. And then what we would do, divide both sides by 90. Now 60 over 90, that's like 2 over 3, right? So that's going to be 1 minus t over 18 squared, like this. And then to get rid of this exponent 2, we would square root both sides. And so when you square root that 2 over 3, you'd end up getting plus or minus 0.8165. So let's just keep this in decimals, and then over here the square root and the exponent cancel out, so we're just left with that expression in the under the square root. So notice there's actually going to be two solutions here, right? So we have to solve for when does 0.8165 equal 1 minus t over 18, and then when does negative 0.8165 equal 1 minus t over 18, like that. And so when you do the algebra on those two values, you'd end up getting these two t values. You get 3.3 and 32.7. And so you might be asking yourself, why are we getting two values? Well, if you remember, if we look at this quadratic in an abstract way, right, there's this second half of the quadratic right here. So there's actually 2 points where we're going to get that volume of 60. But because it's a word problem, we're not looking at that second half, right? Because it's not like the gas is leaking and then it's getting filled up after, right? We're just looking at the leaking portion here. So we would only use this lower value of 3.3, right? So that's going to be the t value when we have that volume of 60, right? This other point right here is going to happen at 32.7. However, we're going to ignore that t value. So we're just looking at this 3.3, right? So when it's when the gas is leaking at 3.3 seconds, there's going to be 60 liters left in the tank. And so now that we have that time, what we have to do is, remember, this is only the first step. Now the second step is we have to find the instantaneous rate of change at that time, or the slope of the tangent at that time, by plugging in this 3.3 into the derivative of this function. So we're going to be finding v prime of 3.3, like that. And so what we're going to have to do is take the derivative of this function here now. Now what I'm going to do actually is first rewrite this function. Just a small tweak, but it's going to make, I feel like, a bit of a difference in explaining the derivative. This t over 18, I'm going to rewrite that as 1 over 18 times t, like that, right? So then when we apply the chain rule, when we take the derivative of the inner function, you could clearly see that it's just negative 1 over 18, right? The constant in front of the variable versus t over 18. It might be a little bit more tricky to see that. Okay, so derivative, simply bring the 2 down. 2 times 90, that's 180. Keep the inner function the same, right? We're applying the chain rule over here because we have a function to the power of 2. So keep that inner function the same, subtract 1 from the exponent, then multiply it by the derivative of the inner function, which, as I just mentioned, is the negative 1 over 18, like that. And then 180, I mean, you could simplify this. You could also just plug in that 3.3 right away here. 180 over negative 18, that simplifies nicely to just negative 10, so why not just simplify it right here? So that ends up being our derivative right there. And so plugging in that 3.3 for the t value, we end up getting negative 8.17. And then what is the units? Liters, right? The volume, the independent, or the dependent variable is liters per, the time is in hours. Or sorry, per hour, right? Per 1 unit of the independent variable. Right, so that ends up being the answer for part B, right? So when the volume is 60 at that specific point in time, or at 3.3 seconds, the tank is, the leak, how fast the leak is happening is 8.17 liters per hour, right? We got a negative here because the volume, when it's leaking, the volume is going down. You could also see with the slope of the tangent here, the tangent is has a negative slope, so it makes sense that we got a negative value right here, right? So that ends up being the answer for part B. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.